Yeah, Councilor Fleeter's got the moves. Get up there and shake those hips, Jimmy.
Your worship, I might have to use my phone a bit. I don't know. I might have some questions in there.
Oh, no, that's fine.
Unless I got them all on here.
No. I will make that comment then, that you may see people going back and forth, okay?
I'm all set. So you just need to unmute your mic when you're ready.
Okay. Okay. Okay, Lucas, calling the meeting to order at
9:08.
9:08. Thank you very much for joining us today for our special council meeting, looking at prefab bridge construction. And we always start our council meetings with our land acknowledgement. The municipality of Tweed recognizes that our work takes place on traditional Indigenous territories, including the Huron-Wendat, Anishinaabe, and the Haudenosaunee peoples. We recognize and respect the histories, language, and cultures of the First Nations, Métis, Inuit, and all Indigenous peoples, whose presence continues to enrich our communities. Miigwech. The purpose of this special meeting today, the purpose of the special meeting is for council to receive presentations from bridge contractors as options are explored for more economical rehabilitation and replacement costs and technologies in the future. Could I have a mover and a seconder to approve today's agenda? Thank you, Councillor Valiquette. Thank you, Councillor Fleeler. Be it resolved that the agenda for the February 21st, 2024 special council meeting be approved as presented. All in favor? Thank you. Are there any disclosures of pecuniary interest? Seeing none. Before I move into the delegations, I have a couple of comments that I would like to share to set the scene about what we are doing here today. The prefab bridge builder forum was an outcome from our potential bridge closure open house held at the Lions Hall on September 20th. On behalf of council, Councillor Fleeler and Councillor Valiquette, along with Deputy Clerk Lucas Wales, agreed to coordinate a prefab bridge builder forum. The intent of this forum was to have prefab bridge builders present to council innovative ways to look at bridge construction, especially in light of us looking at some potential bridge closures. After the adoption of our 2024 budget, it becomes even more critical that we find alternative cost-effective ways to repair and fix our bridges. As it stands, our reserves are at an all-time low. We are fast approaching our debt ceiling, and neither the federal nor provincial governments are announcing any funding programs to help with small rural infrastructure projects. Added to our financial dilemma is that we are required to set aside $11.5 million per year for the next 15 to 20 years to cover future infrastructure costs. This is an insurmountable, non-achievable financial infrastructure obligation. As I reported, Minister Surma denied each of our 5 asks during our delegation at the January Roma conference. As noted, we will continue to look for funds to help address our infrastructure needs. Invitations were sent to 14 prefab bridge builders and suppliers. Our OSIM Ontario Structure Inspection Manual report was sent with the invitations. 7 expressed an interest in attending. We followed up again last week to seek confirmation, and there was no response. Bridge builders contacted included Guardian Rapid Construction Inc., Crawford Dewar, Lessard Welding, Northern Mat and Bridge, Canada Culvert, Sierra Construction, the Miller Group, Bott Construction Group, Algonquin Bridge, Acro, Atlantic Industries, South Shore Contracting, Iron Bridge, and that's the list that was contacted. So we made every effort to try and bring in as many as we possibly could. I also welcome those in attendance here. Excuse me. As you can see, only 2 accepted our invitation. Well, these 2 gentlemen, Dean and Darren from our Armtech, and then we have Tim Lee, who's coming from Lessard Welding later at 10 o'clock. Because we want people to be able to speak freely and comfortably. So I want to thank you both for coming, okay? We really appreciate you being here. We are in a very difficult situation, and we look forward to what you have to share and looking at opportunities to be able to work together. I also welcome those in attendance, both here in the council chambers and via Zoom. Please note that this meeting is considered a regular council meeting and will operate in accordance with our council procedural bylaw, and only council can ask questions. I would also like to note the following this meeting, some members of council will be joining our guests on a bridge tour so that we can show them firsthand about what we are looking at. Also, Council Fleeler and Public Works Manager Ryan Weed will be attending the Ontario Good Roads Conference in April and will seek out bridge builders and share our OSIM report and discuss opportunities to work together. We never use our phones in council meetings, but some people may be using their phones today because they've captured questions as they popped into their heads about what to ask our guests. So just so you don't think people are checking emails and text messages. So at this point, I say thank you very much for coming. Thank you for coming, and let's begin. So I believe you have a presentation. I'm turning it over to you. You tell us how you would like to operate from here. Thank you. Is your mic on as well?
I pressed the button.
Okay, good. Thank you.
It's green.
Okay, thank you.
Okay, sure. Yeah, so yeah, maybe I'll start by giving a little bit of a presentation here. Do I have about 25 minutes or so?
Oh, yes, you have an hour. So
Half an hour. Okay, okay, cool. Yeah, so I'll give a little presentation on what bridges kind of we have to offer and a little bit of specifics into some of your bridges. And yeah, then you can ask questions. So yeah, is the presentation up there? Okay, awesome. So we come from a company called Armtech. The main office in Ontario is in Cambridge. We supply culverts along with, I guess, more standard, what you think of as bridges. Mainly steel, so corrugated steel, if you're familiar with corrugated steel pipe. And then we have these corrugated structures that can be much larger than what you would normally think is maybe corrugated steel pipe, that can be like arches, like open bottom. You'll see some examples in this presentation. So yeah, let's get started in here. So Armtech is owned by a parent company, WGI Westman Group. It's Canadian owned out of Manitoba is the main location, I guess, of the parent company. And we are, go to the next slide there, privately owned. That's our owner there. He's actually 90 now and still working. Jump to the next slide there. So we get into a number of different industries on the top left. So infrastructure, bridges and culverts. I get into the mining industry, the bottom left there. The bottom middle, relining and rehabilitation. I'll talk a little bit about that. That could be an option for you guys, rehabilitating some bridges. And the other ones are not so applicable, but stormwater management, agricultural, building construction. So we'll get right into things. So I took a look at some of the bridges that you've got there. These ones kind of stood out as bridges where maybe we could help with corrugated steel structures as either replacements or rehabilitating them. So there's going to be kind of a couple categories of what I'm talking about. Kind of the rehabilitation side, the new side, both with corrugated steel products. And then we do have a prefabricated steel girder bridge. And I'll go through one of those examples near the end. And by the way, if you have any questions during this, you can ask if that's okay. Okay, so yeah, these are the ones, and you can see the spans are not that big, I guess, and the ratio of span to rise is such that you know, for like the rise is not so small compared to the span. You know, it's not like a long, very low bridge. They're ones that are a little bit higher. That's because of the product that we have. So let's get into these products. So this product here that you see on the screen is called Bridge Plate. It's a corrugated product. Basically, the steel is corrugated. It's been to a certain radius, and also holes are put in prior to that. And then these pieces are bolted together to form a shape. And these pieces can be bent to different radii and make different shapes. So today, actually, I'll mention that later. And then so the different coatings, galvanized to the left and polymer coated to the right, mainly about design service life. The polymer one's more expensive than the galvanized.
Be the life
yeah.
expectancy out of a galvanized as opposed to the polymer.
It depends on the environment. So I would recommend to do like water testing at the site. There are different parameters like pH and resistivity and chlorides and stuff, and that influences how long the structure will last. I guess so.
Not the middle
It
number,
could-
I'm just looking for a
Yeah.
general, like one lasts twice as longer, or you'll get a third longer life out of it.
Oh, out of one versus the other? Yeah, so our our engineering department will design galvanized to like 75 years.
Really?
And they will also, if I ask them for a polymer coated one, they would do that too. But again, it also depends on the site. It could be that a galvanized, when you do the testing and stuff, will only like theoretically work for 50 years. And also there's more than that. It's not just the water, it could be like abrasion and stuff, but with an open bottom, you know, it's probably not as much of a concern.
If I may, just to remind Councilor Valiquette to use your mic when asking a question. Okay, thank you. That's fine, that's fine. Going back to Councilor Valiquette's question, when he asked about the, the life expectancy, and you said galvanized was about 75, like, depending upon, environmental conditions and whatnot. But going back to, he said, if you did the polymer one, what would that add on to the 75 based on the same
Yeah.
10 years? Like,
Theoretically, it could add another like 25 years.
okay, that's all. That's and no commitment. We
Okay,
just, yeah.
Okay.
Okay, good. Thank you.
Yeah.
Please
no
proceed.
problem. And actually, just as a comment, that one on the left there, that has a steel sheeting head wall and wing walls. So that's something we can also supply and design. I can get more into that. Yeah.
This is totally above my head right now. I'm going to be quite honest with you. What does that mean when you say that?
Oh, sorry. You know what? Jump
That's
to the
okay.
next one there. Yeah. Sorry there. Galvanized to the left, polymer to the right.
Mhm.
And steel, you can see that the head wall, I guess, perpendicular to the structure, like just on the face, and then the wing walls come
Oh,
at an
okay.
angle.
Thank you. Okay.
And, so yeah, steel sheeting, we can design and supply that. I'll show you an example, actually maybe that exact example later on. So let's go to the next slide there. So we have a number of different corrugated products, but that one I just showed is bridge plate, and it's the largest corrugation that we offer. So on the right there, you can see DCSP and then SPCSP. So the bottom one is that bridge plate, the one I was talking about, and the one on the top, that's multi-plate. And those designations there are just in the bridge code. So those two products fall under those designations in the bridge code. So bridge plate with deep corrugated structural plate and multi-plate, which I'm not really suggesting probably for these ones. But it's a product of a similar nature. Anyway, it's under the structural plate corrugated steel pipe. And that to the left is an example of an arch in multi-plate. Anyways, so let's jump back to bridge plate, the product that I'm thinking about for some of these. They come in open bottom structures. So here on the top left is a single radius arch. In the bottom there is a 2 radius arch. Basically within the arch there are 2 radiuses, and in the top right there are 3 radiuses. And then there's another one which is the box culvert shape. And basically this one is a lower profile one, and it's mimicking like corners at the top left and right. And so you're going wider with a lower rise. And so that's one there. That one's just about a 4-meter span by 1.22 in rise. And if you go to the next one there, that's a larger one. So about 8 meters in span by 2 meters in rise. And this can go bigger as well. You know, like 12 meters, for example, maybe 12 meters by 3 meters or so. So there's some different options with that. And here you can see an example of a box culvert shape to the left versus an arch shape on the right. So the idea is lower profile. So let's take a look at these bridges again. Oh, sorry. Yeah, so this
Where do you
yeah,
want?
go forward. Yeah, so that one's box culvert to the left versus arch to the right. And then jump to the next screen there. Sorry, I'm you know, thinking I'm controlling it here. That's typically what happens. That's fine. Okay, so you got the structure names to the left there. A rehabilitation potential rehabilitation option. I'm not saying it's gonna work, but potential rehabilitation option, and then the existing, you know, what the span and the rise are. So with a lot of these, what I'm thinking is, okay, you have this structure and it's the span is this, and it's this rise on the inside. And okay, what if you can put a structure underneath it, basically, and put concrete in between our structure and the existing? It's kind of be a strange idea. But that may basically reduce the cost of doing structural repairs on the soffit, like underneath your structure, maybe to the beams and stuff.
Cool.
And the thing is, though, you'd have to make sure that you have adequate foundations, because you know this is an arch, so it needs like footings. But there's a potential of it using just the existing footings there. So if you can imagine, yeah, putting an arch like underneath a bridge, concreting, and then the other thing is you'd still have to, you know, if you're doing guide rail repairs and barrier repairs, you'd still have to do all of that up above, right? So it's probably extending the life of the structure, reducing some of those repair costs. But you know, it's also not a new structure. So you can see here, for example, let's go with this East Red Bridge. And I realize some of these, I think you're thinking of doing a major rehab and not replacement, but let's just look at that one, for example. So the existing is like 7.6 by 2.5, and it's just a single span, and potentially you could slip a bridge plate box underneath it, put concrete in between, and rehab that way. So that's an example. You know, typically we do this relining and stuff with circular structures, or smaller ones. So let's say you have a concrete box that's maybe, well, it can go decent size, maybe 4, 5 even meters in span, but typically it's smaller than that. But let's say 4 meters in span, and you put some sort of arch inside of it. So that's a potential rehab option.
I just had a question about that idea of arches under bridges.
Yeah.
Do you have engineers that will sign off on that? Like, I mean, typically bridges are all engineered. Is that something that engineers would sign off on?
Yeah, so we have an engineering department, and I've asked them someone before about doing a larger one like that, and they thought it was possible. But we wouldn't do the full engineering. So for our I guess specific product, and you know, like the foundation, we're not going to do the foundation investigation and etc. So other consultant would, you know, be involved, but we're not a consultant. We're a, you know, manufacturers or suppliers or supplier. But anyway, they would do that. And there are other, you know, smaller aspects, but like relating to our structure itself and the structural capacity of it, stuff, yeah, we would do.
So just another question here. We ran into this in the past where we had engineers design, removed a bridge and we installed culverts with the engineers. But the conservation authority said, no, you got to put a lot much bigger culvert in than the engineer called for.
Yeah.
Is that something you work with the conservation authorities on establishing?
No, that would be the consultant or maybe you guys. And that is a concern with this method, by the way, with relining. You are decreasing the probably the hydraulic capacity of like your opening and stuff, and they might deny it. So that's a consideration with this. as
So
well.
basically, what I'm hearing is you come up with a design, you have an engineering department sort of approves the design for you guys.
Mhm.
Then we engage someone to work with your engineering department, I guess, and ask any questions to make sure it's a fit. But anything that comes environmentally or dealing with Quinnet conservation is either our engineer or us that responds to that kind of a inquiry.
Yeah. So our scope would be kind of limited to our specific structure,
Right.
if it's a new structure, the backfill envelope, but we would design it for, cars are going over this and the culvert is buried, this deep, structurally, can it take it? Okay, yes, great. Design service life, if you give us some water parameters and stuff, and or we make some assumptions and we design it accordingly and have a package of, for supplying it, manufacturing it, whatever the structure, we can do a drawing package, shop drawings and stuff. Yeah.
Councillor Fleer, then Councillor Valiquette.
Okay, thank you, your worship. So, you said that you would have to have an engineer. So the engineer calls, we would have to get an engineer to go through the project to start with. And
Yes.
if he didn't recommend your type of work, we're pooched. But it's so say the bridge, the rental's culvert, it's a culvert.
Yeah.
Could you do that on your own without an engineer?
Yeah, I guess there are some things that maybe some liability and stuff that we wouldn't take. Like we wouldn't go and do an inspection, an official inspection of that culvert,
Yeah.
and make sure it's straight enough for us to reline it with another pipe. Sorry, that would be someone else. But like if but we can say okay, this design works structurally. If it fits there and it's got the certain clearance and stuff, okay. So there's probably, it may be with that one, for example, that, you don't quote me on this, but you might be able to get away with it with doing a lot of work on your end. And then, us doing,
Yeah, so
the engineering. So you might be able to get away without a consultant with that one, but also like conservation authority and stuff.
yeah,
yeah.
DEA and all that kind of thing we'd have to have done. But okay.
I can understand where you're coming from because you're looking at liability issues here too. So you've come up with a solution. It's up to us to see if that solution is going to meet the standards that our engineer says. The only thing is sometimes engineers can want to go overboard on everything.
Mhm.
And that becomes a problem. Like, they want the Cadillac, okay?
Mhm.
If we can make something work and it's going to be good, do its job, I think that's what we're looking for at this point, because there's no way in this world that we are ever going to be able to pay for a lot of these bridges.
Mhm.
Okay, so we got to find solutions that are going to make it cost affordable for us. So I see what you're saying and I see what you're saying. So thank you very much for that, Peter. Councilor Valiquette.
So like for like, so for relining, you're putting some sort of metal structure underneath the existing bridge,
Mhm.
and then you're backfilling that somehow with some sort of product, right, to provide support and extend its life. How would that be, and I'm just curious, how would that be more cost effective than just ripping out what we have now and putting a new structure on top of our existing abutments and then creating a road?
Yeah, it could be better that way. Yeah, especially if you have to do.
So like
maybe
for,
significant-
so like for like, if we had pick a span, the Rocky Altar Bridge and the span and the rise are the same, would the reline be more expensive than the replacement or vice versa?
I guess you'd have to look at the auxiliary expenses, our structure would be the same cost, basically, if you're gonna replace with the same size.
Yeah.
That's gonna be the same cost. Maybe let's say, okay, footing stuff might be the same. if you're ripping out the abutments and everything, you know, maybe you're putting a new head wall, a new barrier system, everything, you know, at that point, it might be worth it to just do a full reconstruction. So, yeah, but like with that Reynolds culvert, for example, maybe just relining would be a good option for that one, for example.
Yes, Councillor.
Your worship, yeah, and that might have been an unfair question. I think once you see that particular culvert, you would be able to answer the question, I think, without any hesitation. And other things like I really know, I think some of this stuff would really work. Like if you install a head wall, if the abutments are okay, but we would have to have that an engineer sign off on that. But if the abutments are okay and the structure is sound enough, once you put that structure underneath there, that's gonna add to the load bearing on the bridge itself.
On the existing,
So if you
Foundation.
put that structure underneath a bridge that's existing, and it's an unfair question, you'd have to look at the bridge to understand really what I'm trying to tell you. Or ask you. So if you put that corrugated culvert underneath the bridge, is it gonna be load bearing?
yeah, oh yeah.
Okay,
Yeah.
okay, yeah,
And it's the design methodology that we'd use, it's basically viewing the bridge as I guess soil. It's like our structures are soil steel structure, and they work with the soil around it. And when I say putting concrete above the structure, it would be a low strength concrete to like mimic soil.
Yeah.
But thinking about here, it might even be better to just rip out the superstructure of the bridge, especially because a lot of them are deteriorated above and stuff. Maybe keep the abutments
yeah,
and do a similar thing, and then make some sort of head wall.
yeah.
Head walls on either side. So
Okay.
that might be a good option.
I'm just going to throw out a question, looking at how costs have increased. When you look at from your perspective as a company, what it would cost to do a project, and I'm not saying the size of a project, looking at 2019 and looking at where we are today, what have you experienced in regards to inflation on the costs of your bridges and stuff? Like, and because like right now, everybody's looking at, okay, like inflation came on at 2.9. Well, what's happening is yeah, inflation's coming in lower, but the costs that the relative rise in costs that we're all experiencing, that's not going down. That's staying there. So it's the inflation on top of what we've experienced since COVID. So would you say that the cost for, like, you know, what would be an average cost that you've seen, like in regards to materials and stuff like that? Like you've experienced inflation, like, you know, is it been significant?
I actually joined Armtech in like 2021.
Oh, lucky you.
Well, I did some co-op terms back in like 2017 for them, but yeah, so I'm not exactly sure about.
Okay, no problem,
2019,
no problem.
but, since I've been here for these plate products, I don't think it's gone up in price.
Okay.
But
Okay, no, good enough.
Yeah.
Thank you.
Yeah.
Yes, Gloria.
Just want to provide a little bit of clarity for any public who might be watching or in the room. We are already, for any bridge project that we do, regardless of how we do it, already have a separate set of engineers that are always involved, that deal with usually with Quinte Conservation and everything. So needing an engineer separate from this company is not going to be something new. If this is something that council wishes to proceed with investigating, that is already how even our concrete ones go in. We have a separate engineer from the actual construction company. So I just wanted to put that clarification out there for the public.
Thank you. Did you have a question? Please go ahead.
Just looking at some of your spans here, now we have like 52 bridges, so what is your maximum span?
Theoretically, for like a bridge plate, maybe it's a 2 radius arch, we can get to something like low 20 meters in span. It can be 22, 23 meters or something, I think. So the highest I think we've done is maybe 18 meters.
Okay.
But then at that point, your rise is probably significant compared to a lot of these bridges. So I ruled out a lot of them, like There was one with maybe 3 12-meter spans and it's relatively low, for this product I'm talking about, probably not a good option.
Thanks.
So. um, Another thing I'll just mention, not bridge plate, but just normal corrugated steel pipe. I'll show something later, but if the Conservation Authority does allow you to actually split up, you could say, the water course, into multiple, like with culverts, basically, get some large culverts and put them in, rip out the superstructure, and maybe use a similar process. Use a steel head wall, maybe make it a little bit wider, the bridge a little bit wider, make some embankments down the side or something. Yeah, so if the Conservation Authority does allow you to decrease the number of spans, probably environmentally, that's not the greatest option. But cost wise, it would be cheaper.
Okay.
So that's something that could be weighed. Yeah.
Good.
So yeah, so that's some of them there. And then replacement options. So here I just, I think most of them, if not all of them, I just, increase the size from the rehabilitation size and to maybe approximately what existing is, or a little more. So, actually, yeah. So I guess it shows you that we can copy some of those roughly in span and rise for a new installation. Let's look at some footings. If you didn't use the existing ones, potentially we could provide and design precast footings. So the foundation, we can design and supply precast. Cast in place we don't do, but we can provide the loadings for a consultant to do. And also steel footings we also do. But then the soil, like below that, and the bearing capacity of that and stuff, that would be by others to confirm that, like a geotech engineer or something. So there is probably some other involvement there of others, maybe almost any way you look at it with these, at least with these larger ones. So anyway, precast. So that's for a larger span. That might be 12 meters in span or something, a bigger one. And cast in place, this is out in Banff, maybe for about a 16-meter span for yeah, oh sorry I'm clicking through again. Yeah, click the next one there. So that's maybe about a 12-meter span. Precast footings, then go to the next one. Cast in place footings. There's some what is that, some formwork there. Okay, next one. Next one. Next one. Next one. And there, so yeah, so that's in Banff there. The head walls there, that's probably more, that's if you've heard of the company Rico, like a precast panel RSS or RSS or MSE wall. Anyway, that's an option. So that's for a wildlife overpass, and then there are 2 arches there, about 16 meters in span each, I think. We did 2 of those overpasses. So anyways, you can go to the next slide there. And steel. So this one here, you can see it a little bit on the bottom right. So it's corrugated steel that is the footing, but it's not bent to a radius. It's just flat, but corrugated, if you know what I mean. And I think actually there was some concrete poured in there as well. So this is a relatively big structure too, maybe in the around 10, maybe 12 meters. But again, this is like if you're using new ones, and potentially you could use existing. End treatments, steel sheeting, I had mentioned that before. That may be a good cost-effective option. Bin wall, so yep, good, you're there. So to the left there, not right above the structure, but to the left, that's bin wall. Bin wall is like a retaining wall system, or what could be used for abutments. I can talk about that later too, but if you had a normal steel girder bridge, you could potentially use these bins. They're steel bins, and you fill them with granular material, and they could be used as an abutment. And it's instead of making embankments and stuff. This is like a bin to hold material in place. And yeah, so we can also supply those and design. Anyway, and then like above the structure as the head wall in that one before, yep, that one, that's actually a bridge plate itself, but again, flat, but just cut to kind of go around that structure. So the next one there, riprap probably wouldn't be used with these bigger structures, unless you want to extend the structure out, the riprap, go down. Might be a good option in some cases. A wire basket mesh wall, MSE wall. So those are like wire baskets filled with stone, and then they have geogrid going back. It's using the soil or the granular behind the wall to keep it there. Cast in place concrete. We don't do that, but a consultant could probably do it. Some past projects. Okay, now you get to see some of them here. So this, we've got about a 14-meter span by about 4.8. And that is a Rico wall there being used with that structure. This structure, it's pretty, well, it's pretty big, but a large span, like 14 meters, but it's also pretty high. So you can imagine the bridges that you're dealing with, probably that's too high. But this is also not a box culvert shape. So a box culvert shape in this span would be lower.
Just out of curiosity, could you throw a cost behind that?
I could maybe off the.
Sure, sure. Okay, yeah, no problem.
I can pull up some old.
Okay,
quotes and
no,
stuff.
that's good. Yeah, just to give us an idea of what we're looking at for some things. Thank you.
Yeah.
No, definitely.
Yeah.
Thank you.
Yeah, you can bump to the next picture there. The next one. Next one. Next one. Next one. And this was used for actually a water course crossing and a path underneath. Now the path is to the left, and this is in construction. Okay, the next one. Okay, so we jump to one with steel sheeting there. You've seen that structure before, I think, in a previous picture or pictures. This one's again not a box culvert shape, but about an 8.8 meter span by 3.6. You can just jump through those pictures. So the footing there to the right hasn't been poured yet. And now you've got the poured footings in that picture. Here you can see the plate. It's, they're nested pieces nested together. Not the pile right in the foreground, but behind that. And there, assemble these things. Usually you start off assembling it kind of on its side, and then you flip it up. Just one like ring or arch. They come in like 1.2 meter long pieces along like the length of the structure. And then after that, you might do piece by piece or ring by ring. But in the case of a reline, yeah, you still might assemble one ring and try to slide it in. Or you might actually try to assemble the whole structure nearby and then kind of slide it in. You'd have to think about spacing too and being able to bolt it up and stuff. Okay, so here, there's another picture. Yeah, we can keep going. Keep going. Keep going. And then there are tiebacks from the head wall in this case, and they're going back down to the structure. And then other ones would go into the backfill material as well, into what we call deadman. Okay, the next one. Okay, this next project is a reline, and I mean, it's not a classic bridge reline, but you're relining with a CSP, corrugated steel pipe in this case, not bridge plate. This is a different product, a less expensive product, and it's a pipe arch shape. So imagine a circle and it's kind of squished down. And this one's almost 4 meters in span by 2.7 high. And basically they slid a new pipe within the existing, and then there's concrete in between. That's kind of the essence of it. So let's jump through those pictures. There's the reline pipe part of it before it went in. There's the existing And there's inside the reline. So you fit it in there. Okay, let's jump.
One of the concerns that you
Yeah.
had mentioned before is that sometimes it shrinks the capacity of the pipe to be able to, but it doesn't look like it shrinks it that much.
Yeah, like in this case, well, I'm not sure what it was exactly in this case, but we like to see about 100 millimeters. We could probably deal with 75 millimeters clearance between the two,
Okay.
between the outside of the reline and the inside of the existing.
Even on the bottom?
The what? Sorry.
Even on the bottom?
Yes, even on the bottom. Yep. Yep. So that one there, you can see in the foreground, the reline, and then the concrete in between, and then the back a little bit, the existing steel there of the previous structure.
Yes, Councillor Fleeler. Yeah.
Okay, thank you, your worship. So on the reline, if you reline a pipe, you're not really interfering with the bed of the creek. Would you need an EA study? Do you?
You are, if you're doing a full periphery structure in there. Yeah.
Okay,
You probably still need approval from
okay, yeah,
Conservation
approval, but I mean, a
authority,
full
so-
study, okay, yeah, we could.
but
So, and what's the smallest diameter pipe that you could work on for a reline?
for a reline. Oh, well, you can do smaller ones. You just don't get in them, I guess.
Yeah,
So you
that's-
could do small, like maybe even like a, I don't know, 0.8 meter diameter or something, maybe even less. But at that point, actually, with the amount of grout that you have around and stuff, it might not be worth it. But yeah, no, relines can be done on smaller pipes, but the methodology is a bit different.
Okay, and you grout that like with you would apply the grout with a machine, like,
Yeah, so the contractor can put like tubes
Yep.
through in between the reline and existing, and then pump grout.
okay,
through.
yeah,
That's one method. With the structure, with this structure here, I wasn't there personally for it, but I think there are grout ports within the reline structure, so you
Oh, yeah.
hook up a pipe
Yep.
or your grout hose to the port, and you fill it up in lifts.
Okay.
like,
okay.
levels. Yeah,
That
yeah.
might be.
And yeah, actually, with the rehabilitation, maybe because it's a rehabilitation, not a new structure, you might not have to jump through as many hoops, like with the Conservation Authority. I'm not sure, but
Sure. Yeah,
Maybe.
so
So
what I
that's
mean,
something
like,
to keep in mind.
if you have to take that culvert out, you're definitely interfering with the water course.
Mhm.
And if you can reline it, like, I mean, the impact on the water course is lessened a lot by, anyway, we can
Yeah.
figure that out.
yeah, and you don't have to replace the road up above.
Yeah,
You're not disturbing people as much. Probably more of a concern in a higher populous area, but still. Yeah. Okay, yeah, let's jump. That one just shows, kind of how to, we would supply this drawing in our drawing package. And that goes to, some of the design that we do. Yep, okay, so now let's talk about our steel girder bridge. This is an example here. This one's about 18 meters long by about 8.5 meters wide. Length and width are customizable within limits. Our biggest one, I think that we can supply is about 24.3 meters long, and our smallest one 6.1 meters long. And then width wise, I believe this is about the maximum, about 8.5 meters wide. And then the minimum, you know what, I might have to look back at that, but it's might be something like between 2.5 and 3 meters maybe, which you probably wouldn't want to install anyway. So it covers a decent range. This may end up being like a more expensive option than what I was talking about before. And you need abutments and stuff, but hey, I mean, I guess if your existing abutments are good, maybe the best option is to take out an existing superstructure and then just use the existing abutments, do some repair and stuff. So in that case, maybe this is a good option. So anyway, this is an example, Saskatchewan. I mean, this picture is, from Ontario. But the bridge was installed in Saskatchewan. So we'll just go through some of the pictures here. It is a steel girder bridge. We do the design for this. The abutments we wouldn't, but if you remember that bin wall picture I showed previously, we could design the bridge, design the bin wall abutments, and potentially, if we're doing all of that, even design the concrete bearing slabs for the bridge that are sitting within the bins. So in that case, we could cover a lot of the engineering, but then again, still below the bin wall abutments, you probably want a geotech engineer to confirm the foundation and stuff, and probably other elements of the project as well. But in that case, we could do a fair amount of it. Okay, so yeah, in this case, about 18 meters long. Let's jump to the next one. In this case, the lengthwise, it was spliced and plates were put in there. But it would come to site. It is modular, it is prefabricated, so it comes in pieces. And so in this case, this one came in the full 18 meter lengths in 3 chunks. Why there's a splice weight there, I think is actually maybe cheaper to buy smaller beams and put them together instead of buying a big one in this case. Okay, so there's let's go up one at least, or back, back. Yeah, okay, that's good. So yeah, there you can see it. Let's jump down one. So that's we call it bridge plank. So that is actually the structural decking system that sits on top of the beams, and then on top of this would be your running surface, which we could supply if it was timber. If it was granular, you'd be filling up these corrugations with granular. Asphalt, you'd fill up the corrugations with concrete and then put asphalt on top. So there's some different options with that.
One of the biggest things that impacts our bridges is the use of salt. Now, is there a coating on any of this stuff that salt doesn't impact it as significantly as being a raw material?
So we would apply this in galvanized or weathering steel,
Okay.
or it could be painted as well. But I think we recommend maybe spraying down the bridge with maybe once a year or something, to get rid of that residue. But those would probably provide some protection, but maintenance.
Yeah, the salt is a killer for us. Okay, thank you. Just to add to that,
Yeah.
Ryan and Trevor are implementing a bridge maintenance program, both in the spring and the fall, to help us have a better handle on that. So that's a good move on their part. But I was just wondering. Okay, thank you.
Yeah, and maybe consider using an alternate to salt potentially. That might help too. Okay, let's go to the next picture there. Next one. Okay, so here you can see the width of the bridge. In this case, it was brought in 3 sections, widthwise, and then lengthwise, it's the full length of the bridge. So 3 sections total. Let's jump to the next picture. And then the beams are connected through these diaphragms. I guess they're the pieces in the picture going left to right. And then also you have the decking on top. Let's jump to the next one. So there's a truck with one of the pieces. Next picture. And here you got some cranes, and your basically things are prepared such that you can put the bridge there. So you've got, I believe in this case, steel piles. Maybe there's a zoomed in picture later. Let's jump to the next one. And so, yeah, they're going to put this one in. Let's jump to the next picture. So they're craning that guy in. Next one. Now they've got their second one coming in and their third one coming in. There we go. Let's jump to the next one. So putting the actual bridge on, if the abutments are ready and stuff, could take like a day. But then, you know, if you're putting the running surface on as well, maybe add another day or two or something to put the granular or asphalt, whatever, on top of there. But then you also have to, you know, in this case, the approaches are not done, right? So that's work as well. But the bridge itself, you know, kind of putting it on, it's relatively straightforward. In this case, I don't see a barrier system, but we can supply them with barrier systems like a W-beam guide rail, and that can come pre-assembled as well. So you'll see a piece, and you know, on one side there's the barrier system, right? Yep, so we supply everything down to the elastomeric bearing pad there, that black piece there, and then also span wise up to and including the expansion joint, if there is an expansion joint. Yeah, there might be a little bit of welding here, I think, required between the beam and the bearing plate there. But again, it's probably can take within that day to install it in there. And there's a picture of I think basically the finished bridge. There's more to know about that bridge, but it at least gives you kind of an introduction. And then we'll jump to the next slide, pretty much done here.
If Councillor Fleeler had a
yeah.
question.
Okay, thank you, your worship. What's the span, what's the longest span you could do that application?
I think 24.3 meters.
24.3 meters.
Yeah. Yeah, I think that maybe that works out to 80 feet.
How many feet?
80.
80 feet. Oh, yeah, okay. Thank you.
Yeah. And it's not like it comes in at 80 foot, 60 foot, you know, it's customizable
Yeah,
within kind of our maximum and minimum, you know, maybe not like to the centimeter or something, but you know, yeah, I think it's customizable.
so there's no way that you could do 160 foot and do a live joint in the middle? They don't do that? It'd be,
We haven't done it before. It's possible. Again, maybe a consultant would have to get involved and
yeah, the engineering probably be the biggest end of that one.
yeah.
Okay.
And yeah, we are under this Canoe procurement group. You know, Canoe is partnered with AMO via the local authority services. So basically, we're a supplier for their Canoe culvert program, and which I think includes, you know, the bridge plate product I showed before, maybe even bridge in box as well. Is it? I'm not sure about that, but basically, they've tendered out. They've done the tendering process already, and we have won that tender. So you or other municipalities can then buy directly from us, and that is legally okay, if that makes sense, instead of you going to tender with something. So if you're part of that, maybe LAS buying group or whatever, you could use that with the bridge plate product and culverts and stuff. I'm not sure about the bridge in a box product. I'd have to check with that one.
Gloria,
Oh, bridge in box. Sorry, that was a steel girder bridge I just showed. Yes.
do we belong to is that part of our LAS already?
Yes, we
Okay.
joined the Canoe program early last year, and so we have been able to utilize it for some purchasing already, and we're always looking for more options to be able to utilize it.
Yes, please go ahead, Ryan.
You talked about relining CSPs, HDP, stuff like that. Are you able to reline drains as well on these bridges for the outlets? Because we do have some collapsed drains inside of these.
Yeah, like laterals and stuff.
Right.
Coming off the structure. Yep. So that one I showed, I don't think I talked about it, but it did have a lateral, you know, coming off of it. And maybe not every time, but probably essentially every time we can figure out some reinforcement to go around that hole into the structure. Okay. Yeah.
Okay, cool.
Good.
So, that's your presentation?
Yeah.
Well, that's great. Thank you very much. We appreciate all the effort you put into that and very enlightening for us. And still, I'm sure we'll have different questions that will come of it. Does anybody have anything they would like to ask in addition to what we've heard and already asked?
Well, I think that we were talking about the bridges being tear downs.
I'm
This year project is the project with the steel going over, we still have to tear the bridge down.
Well, sorry, this is not an interactive.
Oh.
I'm sorry about that.
No.
Okay, yeah, but like, yeah, there's a lot to think about and consider, and we're gonna go on a bridge tour.
Mhm.
Okay, and we're gonna take them around so they can sort of see what we're talking about and have a better understanding, because right now we're just talking words and stuff. But I'm sorry about that. Okay, okay, thank you though. Anybody else, any questions? You guys are sticking around, right?
Yeah.
Okay. Well, thank you very much. So I think what we'll do is we'll move on to our next group. Now, where are our guests going to go, by the way?
Oh, don't worry about that, but.
Okay,
So do we.
Yeah.
I am, yes, yeah, I'm just trying, they will come with us, yeah.
Do they know that?
Well,
They're gonna head out for an hour.
yeah, they're not gonna have lunch now.
Shouldn't, no.
No. I'll just pull them aside.
Yeah. But you know, once they see what we got, then I think we can get some better.
Oh, totally.
Question.
You know, I think I'm really disappointed.
But if you need any information.
No, other than if you were. Seven meters high, break it to the level of. You got a oh, I realize that at some point, I mean, it's not gonna be, not permanent. Temporary. So you can set it down and pull it in. I don't know.
This one's on there too. Yeah. Okay, thanks. I do that.
Then you come.
We're going on. So I'll send you over. Well, that won't be. No, we're just taking. Yeah.
This president was saying, like, you should ask this, but if Michelle's not gonna ask. Here we go. I knew you would know the signs.
This guy's coming in.
They get back to you.
And they wouldn't.
That's why. Like I was talking about the sale.
Yeah.
These are.
Are you leaving as well?
Yeah.
This will be on YouTube. Okay.
Thank you. Thanks, we need to-
Hey, I got the one. You got what?
He personally bought them up. We're saving costs or we don't. I've even joked about not even buying coffee.
Yeah, you bugger. Might even be a tinted in there for
Oh, yeah, it's pretty small.
Maybe
Evil can evil live here. Just go.
The
conservation authority, they want to make sure that we get our gondolas on
Well, that happens, roll.
Engineer said you needed such a big culvert. Yeah, the conservation authority, no, on this one, like 4 times the size.
I think so.
Of course, guess what happened?
Yeah,
It's fine.
it's really-
I've got a
wouldn't have the
classic
same amount of
for it.
cost.
You know, the Green Bridge. I walked
Probably
over
can't
there,
do
that was a county bridge.
Well, yeah, you'd have
They
to.
said to us, we're gonna change the county road. We will put in a new bridge, it's the Green Bridge. So you can take over, and you would want the Green.
Well, it's got
We-
holes too.
And then we said, let's take it out to a nice walk.
It's one where you just.
So. The engineers, oh, 50,000. Crazy. So we came to the tenders, I remember the night. $250,000. And then she, oh, I guess I screwed up because you'd have to build a berm over the middle and then get a crane. And so I said, we'll just keep the old.
Still enough coffee. Try to make it last as long as it can. I try not to make too much. Hey, so it's I said right now, we're actually in the office that you are not allowed to. And that's- Like, we're doing something. Nope. Paper, no.
Oh, no, that's not right.
And I'll give it her for conversation.
Reline.
Yeah. We're about to year.
No, we're at 6,000 of our 10,000.
Oh, that's how we roll.
No, it's.
I know, you are taking mine.
4,000 for the whole year.
Okay.
Last.
As long as.
We're good.
Yeah.
Yeah.
Okay, we're going to, invite you guys in. Let's get you guys in.
Oh, yeah. You
Okay, let's see.
Okay, all right.
Thank you very much.
Yes, thank you, yeah.
Nice to meet you.
Yeah.
So 11. Come on, we're gonna have one of you,
20 years.
sit here and one will do a presentation.
Yeah.
So one of you can sit there, one of you can sit the other way, okay?
Come on in. I got it.
Yeah, sure.
Yep. And then that means that it's live, if it's.
Well, if it's the same way it's
You got a nurse practitioner.
Well, it's easier.
Okay, we're going to get started here. Thank you.
Just tell me when you need to switch.
This is actually better because sitting down here looking at the screen, you don't get to see my profile.
That's why we sit down too.
There we go. There we go.
Okay, are we alive again? Okay, thank you very much. We now have with us Mike and Tim from Lessard Welding. And,
Point of clarification, it's Northern Mountain Bridge.
okay,
Lessard Welding is one of our fabricators.
Okay, so say that again, the name, Northern?
Yeah, Northern Mat Bridge.
Okay.
You had up the cards. Got some cards on it. I'm at Good Roads every year. Yeah.
Okay, thank you for that clarification,
Yeah.
because I'm just going to read for you just a couple of comments I made at the beginning.
Yeah.
To explain the situation that we find ourselves in.
Yeah.
Okay, and I also thank you again, because when I announced who was invited, I mentioned that you were invited, but you were one of the people that didn't show. And that's because I was told it was Lessard on my thing.
Oh,
So
okay.
thank you very much
Yeah.
for being here. We really
Yeah.
appreciate your
No,
making
no
the
problem.
effort. So this, I'm just going to set some context to how this all got started. The prefab bridge builder forum was an outcome from our potential bridge closure open house held at the Lions Hall on September 20th. On behalf of council, Councillor Fleeler, and then Councillor Valleycat, in a partnership with our Deputy Clerk Lucas Wales, agreed to coordinate a prefab bridge builders forum. The intent of this forum was to have prefab bridge builders present to council innovative ways to look at bridge construction, especially in light of us looking at some potential bridge closures. After the adoption of our 2024 budget, it becomes even more critical that we find alternative cost-effective ways to repair and fix our bridges. As it stands, our reserves are at an all-time low. We are fast approaching our debt ceiling, and neither the federal nor provincial governments are announcing any funding programs to help with small rural infrastructure projects. Added to our financial dilemma is that we are required to set aside 11.5 million per year for the next 15 to 20 years to cover future infrastructure costs. With our current tax increase, we're bringing in about 5.1 million a year. This is an insurmountable and non-achievable financial infrastructure obligation. The Minister of Infrastructure, Surma, is aware of our predicament, and we are keeping a channel open and hoping that something will come forward to help small rural communities. So that just sets the stage of
Yeah.
how this got started, where we're at, and we're looking forward to seeing what you have that might be able to help us go down this path. So thank you very much,
Yeah,
both
no
of you, for
problem.
coming.
No problem. Don, just a bit of background. Jim and I have been, we've known each other for about 6 or 7 years, Jim.
At least,
Yeah. When I retired, I worked for the Ministry of Natural Resources and Forestry Engineering Services section for 40.5 years. I got started, Elvis still had songs in the top 100. I only look like I'm 26. At least that's the way I find by the way I look without my glasses on. But anyways, so Jim and I have had some contact in the past. I know your municipality is no different than every other municipality in Ontario, right? That's without question. You have way more infrastructure than you have dollars, right? The thing I was going to say is that over and above that, you have all kinds of additional pressures, funding pressures, right? Whether it's the social, economics of whatchamacallit, whether it's welfare, whether it's water, sewer, obviously you've got, and of course the roads themselves. So our company is the only company in Canada that does everything. I'll say that right off the top. So when I say does everything, we do all the planning, we do the engineering, we do the environmental approvals. In my tenure with the ministry, I was also a regulator as well as a constructor. I built over my career with the Ministry of Natural Resources 149 bridges, which is really like a Wayne Gretzky kind of record, right? So we do the whole enchilada, which is the engineering, environmental approvals, any additional engineering studies that are warranted. We supply the product. We have a roster of top quality contractors that work as subs. Some projects we do ourselves. We'll just go ahead here with the next slide. I don't know if everybody can see this, but it's from Calvin and Hobbes. It says, they're driving along family and it says load limit 10 tons. How do they know when load limit, what the load limit is on bridges, Dad? And the father answers, they drive bigger and bigger trucks over the bridge until it breaks. Then they weigh the last truck and they rebuild the bridge, right? And of course, the wife says, if you didn't know the answer, you should have just told him, but anyways, so who is Northern Mountain Bridge? Next slide. So all of these are turnkey services, and you see the one that's highlighted there with the dash line. That's permanent municipal bridges. So our head office is in Calgary. Our Eastern Canada operations are out of Orangeville. We have in excess of 500 employees. We've been around for, well, the current iteration, I think for Northern Mat Bridge has been around for 10 years. Before it was referred to as Northern Bridge and Mat. There's just some name changes. We are a wholly Canadian owned company that only deals with Canadian products. Next slide. Okay, so we have the highest health and safety and environmental accreditation that's available in Canada. It's called CORE. And it's I think we went over it was earlier last year. I think we went over 1 million hours without an incident or an accident. Next slide. We care about the communities that we work in, and this is a prime example. We have joint ventures with First Nations right across Canada, where how the joint ventures work is basically the First Nation shares economically in any work that we carry out on their lands, right? And it speaks to reconciliation. It also speaks to our care about our clients and our recognition of the status of the original First Nations of Canada. Next slide.
Yeah, approximately, I think if I'm not mistaken, it's approximately about 130 partnerships across Canada.
Just a quick map showing you Eastern Canada operations. Those are all locations that we work out of. And the one thing that and I'm a fixture of Good Roads. Jim's seen me many times. We talked last year. I'm always available, but the main theme for my presentation today is simple bridges shouldn't cost millions of dollars. And that's the best way to put it. Okay, next slide. Okay, so who am I? Next slide. As I just kind of alluded to, I was with the engineering services section of the ministry for 40.5 years, retired in 2016. I have now responsible for sales technical support to a wide range of clients. As I mentioned, 149 bridges when I was with M&R, and that's an old number now, but 72 since I retired in 2016. At the time of my retirement, I was responsible for over 100 bridges across Southern Ontario for the ministry, as well as the entire road network, forest access road network in Southern Ontario. I mentioned I was also a designated regulator. So if somebody like an entity, not a municipality, because the municipality was exempted from the work permitting process as long as you stayed within the right of way, the road right of way. But any group, any individual, snowmobile clubs, forestry, bridge applications, when they come in, they went across my desk, right? For my approval, my recommendations prior to the issuance of the actual work permit. Next slide. History lesson. So how do we get here? Like, there's an awful lot of vintage people around here that I think were around when Mike Harris was the premier. So this is your planning cycle right now, right? We'll start off in the top left corner. You have budget setting, which you just went through. You've got your budget set, it's in place, right? So let's say you did have in your budget a bridge replacement for this year. So by April, you would have a signed contract with a engineering firm to carry out that bridge replacement. They go off, they do their own thing, and there's no contact from that technical assignment. And of course, in between there, you've got new inspections, which would be a different contract. The guys are out looking to see, what additional issues are with your structures. And then you come up to the application deadline for grants, right? You're calling the engineer up because nobody's talked to him, whether it's Jewel, whether it's Greer Galloway or whatever. No, there's been no discussion whatsoever. That's when you find out that 30-foot bridge is going to cost you over $1 million. That's when you, and of course, Don, you as the mayor, first question out of your mouth, is there no way, is there no alternative? And the answer is always going to be, yeah, but it's more expensive, right? So you go into that, and nobody is saying that you shouldn't spend money on infrastructure, right? And my involvement with this municipality over the last 6 or 7 years, you've had somebody like Jim that has been kind of, I think, a bit of a watchdog, trying to throw some checks and balances in. But my experience, and I deal with municipalities right across Eastern Canada, and they're all folks like you, committed to community service, trying to make life better for local people and trying to keep the infrastructure up and running. But I can tell you without a word, like, nobody in this room ran on the platform that they wanted to kick the ass of infrastructure, right? We know that. So having said that, it's all about trying to minimize the collateral damage in terms of the mill rate, whatever your assessments are. You're trying to rationalize service. That's the reason that you ran. You're trying to keep, costs low and, provide, the minimal amount of service to your constituents. And what ends up happening is with these bridges coming in at $1.2 million, $1.3 million, and typically at a council meeting, you're going to get the director of public works saying, we need to set aside $2.3 million for the 50-foot bridge that's on a road that goes between nowhere and nowhere that 20 people use a year, right? And what happens is, the first questions, one of the counselors will say something like, so what did the engineer say? Well, it said it's got to be replaced or it's going to have to be closed. And we got a report from him this year? No, this is from 2 years ago, that it had to be closed immediately. Well, the reason you're dealing with it 2 years down the road is whoever was sitting in your chair 2 years ago said, well, we can't afford that. We'll have to put it off till next year. Right. And what happens is big expenditures on infrastructure, there isn't the room, so we'll defer it, and we defer it, and we defer it. And at the end of that, you end up with your closures, or you end up basically having to mortgage the municipality for that bridge that goes between nowhere to nowhere that 7 people are using, right? Go to the next slide. So prior to the common sense revolution, this is the way the planning cycle looked, right? So not only do you have all the downloading of the provincial and in this case the county road assets, road and bridge assets and water, sewer and whatnot. So we'll start off with budget setting again, right? So you set your budget for this year. You've decided to do that bridge. You have a fellow that works for MTO, it's called a municipal advisor. That goes out with is your constant companion, always in touch. The municipal advisors were based by old MTO road districts. For this area, that would be District 8. And I think at one point in time, there was like 12 of them, right? So they would go out with your road superintendent, they would look at the bridge, they would look at roads, they would look at other issues related to infrastructure. They would issue with the funding that the council provided, they would issue the tender for the engineering, right? Hire the consultant, and they would review that. They would talk to the consultant about what the standards were. There would be not necessarily talking to them every day, but they would be talking to them at frequent milestone based frames, so that they knew what was coming down the line before they saw it. And they would also make sure the guy would finish it in June and not be still wrapping it up the day before your deadline is for your grant applications. So and as it says, ongoing discussions and milestones with designer, and then MTO would be arranging your bridge inspections, right? And so then at the time when things were being finalized, the design was done, what would happen is the municipal advisor would make a presentation to council and basically saying, this is what it's going to cost, and this is your portion, right? So that's what you're budgeting. You didn't have to worry about anything else. It was already done, the deal signed, you sign the dotted line. You would get then a conditional grant, if it was approved, for the amount to cover your cost. And in between the grant time and budget setting, MTO would also be reviewing the OSIM reports, right? And in 2008, about the same time as the Common Sense Revolution, which really didn't seem to work out, I think, looking back at it now, but prior to that, all of the OSIM reports were based on something called a BCI, which is a Bridge Condition Index. So the Bridge Condition Index, if it was a 3, was in bad shape. If it was a 6, it had probably been replaced in the last couple of years, right? So how they got that number was they used factors called Material Condition Index and Performance Condition Index. So the material, if it's new, it's a 6. If it's rotten, it's a 0. Or if it's missing, it's a 0, right? Pretty simple. And then the performance, it could be new, like a new guide rail, but it's not properly connected, right? There's bolts missing, or there's some other, the way it was assembled, it's not doing what it's intended to do. So that's the Performance Condition Index. And to this day, MTO, if you go online, you can look at the complete inventory of MTO bridges, and it's by Bridge Condition Index. So in around the same time as the Common Sense Revolution was hitting, there was agreement between the Association of Municipalities for Ontario, represented from the engineering community, MTO, that, yeah, your engineer-led inspection is required under the Ontario Public Transportation Improvement Act and the Bridges Act, that it was dummied down. And the Bridge Condition Index performance, that was all out the window. So what you're left with is a couple of pieces of paper with information that, quite frankly, was copied from the previous one, right? And photos that should have been taken this year when you inspected it. Although I did some asset management stuff for Sterling Rod in 2017. And what I saw when I looked back at 4 successive bridge inspections, I showed George Burkett, Bob, the mayor, and Roxanne photos of the same Tim Hortons coffee cup sitting on the curb of the bridge with the hammer beside it, 4 years apart, right? And it speaks to the fact that because it's been dummied down, there's a lot of municipalities that believe, especially in these parts, that a good bridge inspection for OSIM shouldn't have to cost any more than $200, right? And there are municipalities in this area that if I'm an engineering consultant and I apply to get my, your tender, if I put in any more than $180, I'm not getting it. So you got to stop and think about that. Maybe you might have 10 bridges, but somebody's got to drive there, right? There's fuel. Somebody's got to have lunch. Maybe if it's company from Kingston, maybe they're going to stay overnight, right? How are they doing that for $180? And it's an engineer-led inspection, right? What that translates into is it translates into usually engineers in training, EITs, or technologists, or just somebody from that office going out and taking that. And they're looking at that as a loss leader. Maybe at the end of this round of OSIM, I'll give you a really nice report cover and I'll do a nice forward in there. And, council in reviewing that, look at these guys did a really good job, right? We're going to replace that 60-foot bridge, on Cooks Road this year. We should get those guys to do it. Well, of course, it was a loss leader, right? And what I've seen time and time again is it cost me money to inspect your bridges. So yeah, I have no problem helping you out, but I'm going to try and make this as complicated, as difficult as possible. So you need me to hold your hand through the whole process. And you're into stuff that, maybe you understand the scope, maybe you don't, maybe, there's been lots. I mean, we're doing one this spring in Quinte West. Simple box culvert was proposed. It was going to be around 900,000. They tendered it last February, and it came in, the lowest price was 1.3 million, right? And it's basically a road that goes to 3 houses, and the road ends about 100 yards up the road. So we're doing that this year for around $400,000, and we'll do it in 5 to 7 days, start to finish. So I guess what I'm saying is that like when I was with M&R, when I got my bridge inspections done on the 100 bridges, actually it was 124, but I paid on average $2,500 per inspection, right? But for that $2,500, I got something that you guys don't have for your bridge. Nobody can go to a file right now, unless maybe it was replaced in the last 10 years. I could ask Lewis to go and grab whatever file we want to talk about, say, show me the plan. You don't have a plan. You have pictures, you have reports, right? So I would do that. I would do hydrology to check to make sure the opening size was adequate for when it had been constructed. And would also do what we refer to as a simplified analysis or analysis using first principles to make sure that the bridge could still meet the code, right? And that left me in a position where I had guarantees for each one of those structures, and I didn't have to go back, later on, have a pay separately for an evaluation, whatever. And so I guess what I'm saying is garbage in, garbage out. And then we look at the contact, as I talked about with the first slide, which is issuing that assignment to that engineering firm. And then nobody ever talking to them for 3 or 4 months. You don't know what's going on. Maybe 2 months later, hey, have you started? No, we're gonna get going on it, whatever. And typically what I see is issues that come up is because somebody realized at the other end that, you know, they've been billing all along, but they actually hadn't done, there's no meat to go with the potatoes, so to speak, so that they were under the gun. And, you know, I was just talking to at breakfast this morning with George Burkett, and he was talking, you know, a Kingston area firm that didn't core a bridge. So when they came up with the new deck and all the plan and everything, turned out there was 10 inches of asphalt on the bridge deck. So when they put the new deck on, all of a sudden they were 6 inches lower than the rest. And the engineering consultant in that case was trying to say, well, you know, we can kind of you could probably shave some asphalt off, or we can you know, adjust the road coming up to it. And as George so aptly put it, he said, we do that, there's going to be 3 people will be targeted here. It'll be council, everybody doing the dip to get over top of this, council, the contractor because of their big sign, and you, right? Because of your sign being there too. So
Well, one of the things we're really interested in hearing from you is like when you mentioned the Quinny West Bridge at 3 point some million and you doing it for 400,000, I'd like to get to seeing, like, you know, when you looked at what we have going and everything, what is it that you can do for us? Because like, you know, even 400,000 where we currently are is expensive, but that depends on the kind of bridge you were looking
Yeah.
at. But let's see, like, you know, so I assume that
okay.
the way things used to be, you are now going to provide that, like, you know.
Yeah.
So let's move to that. We
So
could.
when I started with the ministry, it used to, when I first couple of bridges, it took 5 weeks to 9 months. Right? Because we would take timber out, we would take stuff individually, would work remotely, hope the generators would hold up and everything. So what I learned over my time with the ministry is if I modularize things, if I compact things, if I come up with a work plan and I use today the same work plan that I was using 26 years ago, and that allows me to you know, typically a small structure, 5 days from start to finish. Start on Monday and Friday, everybody's getting cleaned up and we're putting equipment on floats and it's leaving the site, right? There hasn't been a municipality that I've dealt with, and I've dealt with dozens of projects under our belt with first with Lassard and now with Northern Mat the last 4 years. There hasn't been a municipality in this province that I haven't saved them at least 350 grand that I know that they don't have, right? And again, going back to what I was saying a few minutes ago, nobody's saying that you shouldn't spend good money on your infrastructure. You should spend it wisely. And you should look at all the options, and you shouldn't be, you know, as that old saying goes, insanity is the act of doing the same thing over and over again, expecting different results. And, you know, from the discussions I've had with Jim and my knowledge of what's going on in this municipality, and you're not alone, that's exactly what you've been doing, right? You've been doing the same thing over and over again and being disappointed at the end, either in the cost or in what you were told, what you ended up with, or long-term maintenance issues related to. Next slide.
Go ahead.
Okay, so
I just have a quick question for you. So,
sure.
You correct me if I'm wrong. So if we say Northern Mat was successful with a tender, we're just throwing that out there. In the past, we deal with, you know, and I think Jim's probably told you, all of a sudden an EA study comes up that's not good, or the flow test with the Conservation Authority isn't adequate. So the minute you are engaged, that goes away with us. You look after
Yeah.
all that.
Yeah,
that's
that's
what we get
that's
to now.
exactly
It'll be
what
fun.
I'm saying.
Okay.
So I know what the CA is looking at because I was looking at the same thing when I was with M&R, right? If private individual a group, a cottage association, or turn the clock back to prior to 2008 municipalities, right? We want to make sure that there's an adequate opening underneath. The 149 bridges that I did with the ministry, they were all in extremely environmentally sensitive areas, right? Like they weren't urban. I'm gonna say 14 out of the 19 bridges that are in Algonquin Provincial Park, I installed them. Right, so you get a sense of, the reason it's a provincial park is because there's something very sensitive there that we're trying to maintain, so.
Could I just ask one follow-up?
No, not right.
So these are answers, Louis sent me some kind of questions that you guys had, so this is, just a one-liner, answer. Does your company do all the engineering? Yes, we do. And we don't use the same engineering firm, I might add. We have a roster of firms, that are either, limited by capacity, can't do it, right? Can't help you out there, Tim, sorry about that. Or limited geographically, because obviously we're not gonna get an engineering firm from, let's say, Timmins or Thunder Bay down here to do a bridge in Tweed. And I work with companies like right across Eastern Canada. As I did a bridge in Newfoundland about 4 years ago, and did a couple in one in Nova Scotia and a couple in New Brunswick 2 years ago. Do you design build? Yeah, that's what it's all about, right? It's a modularized design. It has components. It has established timelines. It would have to be a pretty funky looking flamingo if I've not seen it, right? Like I've seen some of the areas I worked in, literally when you're working on the bridge, the 49-ton excavator is shaking because you're on a corduroy road, right? The soil conditions, settings, like when I go to a site, I'm not just looking at the bridge, I'm looking at how the bridge is sitting in the reach of the river, right? Because you can be totally, like there's one of the things my predecessor, but the people that came after me are having difficulty with, is they'll go into a site and they'll try and recreate what I did, thinking that it's been like that forever, right? They go there, there's issues, they're gonna try and change it up. So they're gonna go to great lengths to try and maintain that. I never had that sense. What I did was I went in and I knew that in Ontario, I don't think there's any trail, any road that goes someplace that nobody has ever been on, right? That's a fact. It always amazed me that I would go into areas where I would say, geez, it's been, like nobody was really ever here. And then you go a couple of steps and there's a garbage dump, right? All old tin cans from 1920. There was probably a mining site there. They were doing some exploration, just left it. So I guess what I'm saying is you have to pay attention to how the bridge is influencing the river, because you're not going to change the river. You're not going to change the water course. You got to cohabitate with that. Okay, so as we already talked about, so that's all the pre-work with conservation authorities department, says DFI, I should say DFO, Department of Fisheries, Ocean, and environmental assessment. So those include the applications for fill permit for the Conservation Authority in areas where there is no Conservation Authority, which doesn't really apply here. That's work permits. What we do is we do not avoid at all costs going into the water, right? So a little bit of a bridge 101 lesson. We've all seen bridges that look like this, right? And the water's somewhere up on either side of the abutment. So these are the abutments, the bridge is up on top here. If I could do it this way, I would, but anyways, so we've seen that. What that tells me right away is that bridge encroaches the channel, because the normal channel would be like this, right? So one of the rabbit holes you can go down here is first thing the way you're doing business right now. First thing an engineering consultant is going to say, hey, we got to get a geotechnical report done, right? Can't do anything there until we get the soils report, and then a geotechnical engineer is going to advise us. So when we're in situations like this, and they go right down here or just behind this wall, it's still in the channel, right? So 100% of the time it's going to come back, it's really crappy, because the channel is it's a dynamic fluvial system that's always moving, always, so it doesn't really compress. That's why in certain circumstances you can step into the water and go right up to your kneecap or higher in mud. Or you can step into the sand and it's nice and hard to stand on, but it's not cohesive, right? And it's subject to erosion. So what you end up with when you do exactly what I was talking about, doing that geotechnical stuff, and you're going to try and recreate exactly what's there, is that you end up with the town of Huntsville in 2018 at a tender for an 18-foot bridge. And the 18-foot bridge went to 3 seasonal cottages. They had a budget of 600,000. Lowest price was 983,000. They didn't proceed with it. Well, when I looked at, I'd already offered to the town when I was with M&R. I knew about that particular crossing. Somebody had given me a heads up, and I said, if you buy the bridge, I'll show you how to put it in here, right? Free, right? Oh no, we can't do that. Our guys don't do any construction, whatever. So they waited. They had this thing. So when I had a look at the actual drawing for this bridge, they were using 90-foot piles to support a bridge that was only 18 feet across, right? So when I had a meeting with the director of public works and one of the councilors afterwards, I said, the bridge just has to be longer, right? If you make the bridge longer, you get out of the channel, you get back over here. And like there are exceptions to this in Ontario. It's not 100% blanket, but I'd ask all of you, what are the size of the piles underneath your houses? You don't have any, because the soil is generally competent and generally capable. Most of all of the infrastructure that you have existing was done before geotechnical was in the dictionary. They didn't do that, right? And there are very, very few examples of those older bridges with some sort of massive settlement displacement, right? It's not like the bridge that was put in 1930, the abutments rolled over or it slipped and sunk into the abyss on one side, and that's never happened, right? And when you look behind that, when you start to get out of the channel and get into the roadbed, the road's been there longer than the bridge has, right? So what Huntsville ended up doing, they ended up doing exactly what I told them was, they replaced that 18-foot bridge with a 50-foot bridge. And did it for around $300,000. Like that was before COVID, but you get the message that I'm trying to get across here. If it's it's sold on the basis of, well, if I do it like for like, then I don't have to do an environmental assessment. Environmental assessment is not a big deal. So you have A, B, and C. Don or the CAO can, on a piece of paper, say it's not going to impact anybody, put that statement, put it on file. If required, send it to the Ministry of Environment. A B is we gotta let everybody on the road know what our plans are, right? You gotta do a mail out campaign. You got 60, 90 days, whatever, to respond back. People will be, have lots of other issues that they, of course, will raise, they really care about the bridge as long as you're gonna replace it. And then a C involves, would be major infrastructure changes in downtown that affect the whole community, right? But it's not a big process. Typically, you're looking at about a $7,000 or $8,000 venture to change things up versus couple $100,000 for piles, right? And dewatering and steel sheet piles and concrete and everything to build something exactly where you should be building it, right? So, next slide. So our approach, okay? So what we do is we look at, confirm the scope and condition of the existing structure. Always start off with getting a copy of the OSIM reports as Lewis had already provided. A lot of those structures I looked at with Jim a number of years ago, they haven't got any better, sad to say, but and then what we do then is we do an analysis and we come up with a budget. So the budget, I just gave George a budget this morning. So a budget is not a formal quote, right? It's a document that I developed. I didn't develop the word budget, but I do it on that basis so that you as a council here can say, hey, Northern Mountain Bridge is saying budget is $588,000. Okay. So that's what you got to look at putting aside. Okay. So I present that to the client. Council, municipalities like yours, mull that over, whatever wherever they are in their budget deliberations. And then they come back and say, yeah, we're interested. We'd like to proceed. So the very next thing I do is I do an invoice, formal invoice, or not formal quote. And the quote invariably is lower than what the invoice is, because than what the budget is. Because I learned over that 40.5 years, if I needed $970,000 to do something, that I better make sure that I've got everything covered, because if it was 971,000, I wouldn't be doing it, or there's no way I'd be able to go back and get additional money. And we don't want that, right? You want to have cost certainty as much as possible throughout the year, because I know you would be doing reviews, quarterly reviews where you're at with your budget and things that have come up. But as much as possible, starting that process, you want to have cost certainty.
So then if I can just get my head around it, so what you would do is you would provide sort of an estimated budget so that council has something to contemplate about what they're
Yes.
thinking it would cost. But then if they wanted to proceed, it would have to go tender.
No, so
Okay, that's interesting.
no, so it varies. Some councils have said, no, we've got to go the full tender route, and that's in our administrative guidelines, whatever. Other municipalities have tried, like let's say Huntsville, failed. They didn't have the money to do it, so they could prove, without question, they could prove they were saving taxpayers' money, right?
Gloria, if I may, can we sole source like that, or are we obligated?
Our procurement policy does have certain conditions that allows us to sole source. I would have to pull the policy though to tell you the 5 that they are.
Yeah.
Okay, thank you. Jamie, you said you had a question. Did you write that down?
Yeah, you mentioned something about pricing pre-COVID. How have your prices been affected since then?
Well, everybody's prices, right? Just ask poor Galen Weston, right? Anyway, but steel, right? So steel was steel and wood came after toilet paper. right? Remember, we were all limited to one package, whatever, and the price shot way up. Well, the way economics work in Canada, in case you weren't aware of this, it's the gas model is how I like to describe it, which is when prices go up, they go up like a rocket ship, right? When prices come down, they come down like a feather. They don't always, they never always make it back to where they started. But after a while, you get acclimatized to paying $1.45 or $1.65 per liter. Still no different. You just have to go for a drive through Toronto to understand that steel is in demand. What you don't see in the sky in terms of the towers, in terms of the condominium, high-rise, large commercial buildings being constructed, there's an equal amount that's taking place on the ground, right? With all of the Metrolinx, subway, Ontario line, all of that stuff all happening at the same time, and then plus infrastructure. So what we saw from January of 2020, just before COVID, till January 2021, price of steel shot up 38%. Part of the hindrance here in the pricing is so we have virtually no domestic steel production. We have some, like Stelco makes nails and screws, right? Dofasco does some different, they roll plate steel, right? They do steel for automotive, like for the press to make doors and whatnot. And they do some steel sheet piling, limited amount. Algoma Steel, they're doing tube steel, like 90% of their operation. There was another company, Cisco, that was located in Nova Scotia. They're out of business. They were subsidized heavily for years. Prior to Donald Trump, it was a free trade agreement. He put the tariff on steel, aluminum, and stuff until all the parties got together for the Canada-Mexico trade agreement, which severely limits the amount of steel coming from Asia. And not that we would ever use steel from Asia, but people in BC and Western United States did, right? So you have that. We can import, Canada can import steel from Europe, but they've got the same massive infrastructure projects underway. They've got similar problems with housing and stuff like that. So it's really not viable. So what it went out, they had the tariff was lifted, but the steel price never came down, right? So all of the people in between the steel producer, distributors, whatever, everybody used that as part of their new business plan.
And like you say, everything becomes normalized at some point and then we just accept it.
Yeah.
So, okay, back to this then.
Yeah.
So this is,
Okay, so and like I said, so we go formal quote to client, right?
Mhm.
So that's the price we'll do it for, and it will be less. I guarantee you that it will be less, because when we do the budget, there's a whole bunch of unknowns, right? That we don't know about. I use my experience. I have several tools that I've developed over the last 40 years that I maintain that allow me to get into the market, that market number. The quote will come back. The quote from our standpoint, some municipalities enter into a formal contract with us. Other municipalities just sign the quote, right? Whatever you feel comfortable with. The other thing that goes with the quoting system is that there is no outlay by the municipality, right? Like there's nothing, you sign the quote, you agree to the terms and it's all laid out, it's all documented in the project plan, which would be developed as part of the quote. You don't, like the milestones are, hey, when the bridge is ready to go, you pay for the bridge gets delivered. You know, construction starts, we're talking about a time frame of a week, right? Maybe at most 7 or 8 days until we're all said and done. And that's when the final invoice would be issued. It includes a contingency of 20% on the construction aspects of the job. And it's used like any other contingency, which is it's not ours to figure out what to charge, what we're going to charge to equal that amount. It's through joint discussion because it's to cover unforeseen circumstances. Okay, so we confirmation of scope and condition, just go through these quickly. So we do that information gathering, we do the site inspections, we have discussions with clients related to use, local issues and priorities. Because I always thought, you know, when I was fixing bridges in the middle of nowhere that could kill people, that the public, if they came across me, would pat me on the back. But usually I just got a kick in the rear end because guys that had camped in there and everything didn't like the fact that it made it safe again. So more people are going to come into their paradise. Next slide. Okay, analysis budgeting, detailed analysis, as I've already covered, existing conditions and why they occurred, right? So if somebody did something, it sounds pretty simple, but it gets overlooked all the time, which is somebody did something 30 years ago and it didn't work. So why would you want to redo it, right? You have to be able to separate that out and understand what forces were at play, what actions have to be taken. Waterway conditions, environmental issues, access for construction. I can tell you the places that I put bridges in, a lot of people would think twice about ever driving into those places. And I was going in there with 49-ton excavators and tractor trailers. Okay, budget estimate, follow-up discussion with client. Next slide. Okay. Formal quotations, we just got through there. And what we do through to go from the budget to the quote is we simplify it as much as possible. We don't make it more difficult, right? And the roster of contractors that I work with and the engineers that I work with understand that. We don't try and add little details that we know are going to cost money, like let's say metal curbs with drain pipes attached to the deck because we think there's going to be a water issue. That's out the window. It's basic, it's safe, and it's efficient. Okay, so here's okay, so this is an example here. So this is Snake River Bridge. This is Chatsworth. Okay, 18-foot span, concrete deck, built 1940, 20-foot deck, low volume road, bridge went across an agricultural drain. And just like you guys, they got 51 bridges. I don't think you got 51. I think it's 37. 52. Oh, I'm thinking of starting right. My bad. That's why, just like you guys. And they told me, and you guys would be in a different scenario than those guys, which is the director of public works said, I said, if we get a surprise bill for 50 grand, everybody's taxes going up 3%. Right. And it's got to be similar here with you folks. So it was a 1.1 million replacement cost for this bridge. Go next slide. Yeah, and I think we kind of skipped ahead. Just go back a couple. Yeah, one more. And I think that's, yeah, I think that's it. So you can see the condition of the bridge, right? Guy's telephone line hanging from the side of it. The barriers consisted of the cast in place, really ornamental stuff that Department of Public Works would have did it in 1940. And the other side was because there was no barrier there, so they had Jersey barriers for the last 3 years. Right? Just go forward again. Very small drainage area, it's like 0.4 square kilometers. Right? Next slide. And next one, there we go. That's what they ended up with. Right there, and I got much better photos than that. But they ended up with, and that was everything all in. That's the environmental approvals, that's the EA, that's the engineering, that's the bridge, right? 20-foot wide deck on it. That's the precast concrete abutments. That's what we use. The precast concrete abutments are basically a meter wide, half meter deep, and whatever the width of your bridge is, plus a couple of inches on each end. And basically the way it works is we start on Monday. We start Monday morning at 8 o'clock. We take out everything that's been scheduled to be taken out of the way. And we have equipment both sides that are doing that. There's no in water work. We use, and just go another slide. And okay, one more. Yeah, so it's 281,000. That's what they end up with. You can see the old abutment underneath the far end of the bridge there, with the new bridge sitting on top of it. And that was by Wednesday, the bridge was in place on top of the abutments.
Yes, go ahead, Councilor Bellika.
So just looking at the picture, so the old abutments there, but you said you put in new abutments on the backside of those?
Backside of them,
Okay,
right?
thank you.
And again, it's based on the principle, we stay the hell out of the water. If the abutment, like the one in Quinny, we gotta take the abutment out. And the reason, like their plan originally was if they couldn't get the box cover, which they couldn't afford, they were gonna go in and try and repair the old concrete abutments that were there. But they're all cracked, split. You know, if you're gonna try and repair that, you're gonna have to reduce the opening size, right? Because you're gonna have to put concrete on the water side to beef it up. And at the end of the day, the one in Quinny, I can guarantee it's not even part of it's on bedrock, but I guarantee it's not anchored to the bedrock. It's just sitting on bedrock, right? And that abutment now is not subjected to any forces related to the weight of the bridge or the weight of the traffic on the bridge. It now acts as a retaining wall, and it'll last 100 years, right?
Just to read, they were quoted 1.2 million.
1.3.
They were quoted 1.3 million, and then at the end of it, it was 200 and change.
Yeah, 281,000. And when I sent them the final invoice, right? This is, it was kind of funny. I didn't know what he was getting at. When I sent the final invoice, Director of Public Works called me and said, "Yeah, I got your invoice." You know, he said, we normally pay within 2 weeks. I said, "That's fine." He said, "Just to let you know," he said, "our CEO said he was gonna get the invoice made into a plaque." And I said, "A plaque? What are you talking about?" Well, he's been in that job for 38 years. And he said this every time the only time he ever got an invoice, it was less than what they thought it was going to be. Because going back to that, the contingency, we didn't use it. You know, so they saved themselves like 38,000 bucks. You know, it didn't save them, it didn't cost them that. So
And what year was this one?
that was November of this past year. So they did it for 281,000.
Sorry, did you want to say?
Just, I'm just trying to figure out your concept here. Sorry if I sound kind of. So instead of using the abutments, what you're doing, you're taking an 18-foot bridge, you're making it 50, and you're using the road itself as.
No, so the concrete abutment sits underneath the end of the bridge. It has to be there to support the end, fully support the end of the bridge, and to transfer that dynamic load from the truck and the weight of the bridge into that. It's the like I said, it's a meter by a half a meter, It actually sits on 8 inches of compacted granular A material with a geotextile, and that's all which compacted to 100% standard Proctor density, which is just like this desk, right, in its integrity. And like I said, there's no on-water work. We could do a bridge right now if you wanted to, right? Because we're not going to be near the water. We're not going to interfere with the water whatsoever, right? If you start to get into these things, well, we're going to put these piles in, we're going to drive the sheet piles in, we're going to de-water and everything like that. There's, depending on whether it's cold water or a warm water fishery, there's timing restrictions. You can't work in the water when that stuff is on. Well, the stuff we're doing here, 365 days a year. Next slide.
Councilor Flitter?
So,
We'll check on our guests. Go ahead.
so if the abutments are good, deemed good, safe by the engineer, then we're all set to go.
Well, what I would say is we won't, it would be. There would be circumstances where you would use them again,
Yeah.
right? Typically the kind of wear and tear that we see is ultraviolet, sand, salt, wear, right? Temperature changes, over 50, 60 years. I know I've changed over 50, 60 years, right? But the disintegration,
Yeah.
like the bridge that I showed, the Snake Creek Bridge, the side that still looked like the barriers were good. Well, if we all spent 15 minutes and stayed at each one of those posts, we could peel it right apart, right? There was no integrity left. We couldn't actually, we cut them and tried to pull them out, but as soon as you put a chain on them, they just disintegrated. So this one is up the road from you guys. This is in Madoc, right? Center Hastings. So this one was, it was a 2-span structure, as you can see there with the center pier. In 2015, it was put out to tender. The engineering firm, a name that you guys would all recognize, which I'm not going to say, their idea was, we're going to beef it up. We're going to, increase the size of the center pier. We're going to put new concrete on the front. We're going to anchor that new concrete into the back and a bunch of other, and we're going to put a steel stringer bridge with a wooden deck on top of it. The lowest price came in at over $900,000, right? Municipality said, no, we're not doing it. They let it go. This particular bridge, you can see the lower picture, just up there where that last tree is overhanging there is Highway 62. It services the only recreational facility in Madoc. So they have an outdoor heated pool. They have, I think it's a indoor lawn bowling. They have baseball diamonds. When I met the Director of Public Works, the councillor, and the CAO, just to the right of that lower picture, I was standing down there looking at what I could not believe how bad this bridge was. And I said to the CAO, Alex, I said, so when did you close this? He said, oh, we closed it last week. And I damn near fell in the water. I couldn't believe it. The reason they closed it was this was just the start of COVID. So we're closing it because the pool's not opening this year. And I said, well, when was the last time there was any traffic over it? And the Director of Public Works says, well, the propane truck was just in here about 10 days ago, drove over top of this. And the going back to the design that was selected, Conservation Authority said there's no goddamn way we're going to let you do that. They were objecting to the design, and they had they gotten within their budget, I think they would have been in loggerheads, because this is in a regulated floodway. The flood elevation is the same level as the deck. So if you're going to make it narrower, it's going to back more water up, right? So as part of this, the approval process here with Quincy Conservation, so what we had to do was we did the hydrological analysis, which is standard. And in this case here, we had to do a hydraulics analysis on the existing bridge, the new bridge, and if you're familiar with the area, Tim Hortons and McDonald's up on number 7. There's 2 box culverts there, one that goes under Highway 7, one that goes under Highway 62. And there's the Victoria Bridge, which is just around the corner from this location, just before you get into the village of Madoc itself. So what we did was we did the hydraulic analysis to show what each one of these things could pass, and how my idea of just going with a single 60-foot bridge, how it would work. And it was mathematically the best option. And actually, they ended up subsequently doing a review of the flood damage reduction mapping. And the flood elevation at this location actually came down because the bridge was no longer an impediment to flow. Next slide. Much larger area, 74 kilometers. The one I talked about previously, 0.4 kilometers. This is 74. Big area. 26.1 cubic meters per second would go under that bridge in a flood. So 2 spans, it talked about 18-foot spans, each one of them 16-foot deck width, and the pool and park. And when I saw exactly how bad the bridge was, all I could think of, and that's why I almost fell over, was the parade of minivans going in and out of there every summer to swim lessons, pool parties, baseball tournaments and stuff. And one of the things going back to the OSIMs that we encountered with this one was nobody ever said anywhere in those OSIMs that the actual steel beams were stitch welded together. So they weren't, when I showed you the beams going across there, they had pieces of checker plate, and they're all different sizes that were stitch welded just to one side. There's nothing on the other side, right? And they had little Mickey Mouse pieces of looked like light railway rail that was bolted to the bottom of it. And for the consultant originally to have said we're going to increase put more meat behind here, the one corner, the far end of the bridge, there was a concrete, I kid you not, there was a concrete block, not laying like it would normally you'd use it for in a building, but on its side to support that end of the bridge. And there had been this propane truck go across there 10 days earlier. So in that case, they got 37. And like I said, it was tender. They thought 700, it was 980. Next slide. So the solution was a 60-foot clear span. Again, we're going back farther, right? We're getting into some meat that can support the bridge. 16-foot deck width. They did it for $221,000 total. They saved so much money, and if you don't believe me, call Alex Kelly and ask him, because they had budgeted that year for a brand new snowplow. They saved so much money on this bridge that they bought 2. They got authorization to buy 2. The originally was going to be around $322,000. But I also have another model, right? So there's the one where we do everything from start to finish, and we have you out there, we show you, we keep you posted, we give you updates, everything. And there's another model where for Center Hastings they have a water sewer work crew and have a roads crew. So what we did, the other model that I use, which is you have standing offers for equipment, you have standing offers for granular materials that the licensed operators will sell to you for 10, 15, 20% less, but they would sell it to me working for you. So why don't you buy it? You have it delivered to the site. They provided labor to actually do the physical connecting the post pockets, connecting the bridge. They arranged for the crane. And paid for the crane, so there was no overhead or markup on our part. And the added benefit was, I was disappointed that we didn't get a lot of press coverage, because usually when I do bridges in communities like yours, word gets out, everybody's been waiting to see what the hell council is doing with that bridge, and then they find out it's going ahead. We didn't get any press coverage, but what we did get was we got ratepayers that were walking their dogs down, checking it out, and they saw their guys working on the bridge. It wasn't some big city Toronto contractor that was coming around here to the office at night with a vacuum cleaner trying to vacuum out all the loose change out of everybody's desk drawer, right? They saw the guys that they would normally be ticked off at because they left a garbage lid in the middle of the road, or that had done a piss poor job of fixing the pothole at the end of their driveway. They saw their guys doing it, and they know.
Okay,
there's
that
money.
completed project cost of 221, did that also include the municipal contribution?
That's what
That's
the
the total?
ministry, that's what this municipality paid us.
Okay, but they had their contribution on top of that.
They already had, the money had been sitting there.
No, I
in a
just want to
special
make
account.
sure that that didn't include the gravel that they brought, the order.
No, so
Yeah.
that's, so
Okay.
that's 221, and it was 135. So that was the saving. Yeah, by doing that. And part of my budgeting stuff, when I issue a budget, I have an indication, because I have the one of the tools I use, I can calculate that out based on what I know to be current market values for gravel, for equipment and that sort of thing, and I can pinpoint, like, let's say with the Snake Creek Bridge, because it was shorter span, it was around 85,000 is what they would have saved if they would have done that. But they looked at it and said, we got 7 guys and we've got stuff for them to do. And if they're working here, they're not doing that other stuff, right?
Yeah.
It's not that everybody's got
Right.
extra guys that don't have nothing to do, right? Next. Okay, so
Can we
yeah.
speed this along? Tim,
Yeah.
as
Yeah.
we're
So
running-
there's what they ended up with. Right there. Okay, next one. So these are just, we're almost done here. So these are municipal bridges like yours. So that's Township of Ryerson, it's north of Huntsville. And give you some kind of setting. That's Snake Creek, another photo of Snake Creek. That's one of the bridges in Algonquin Park that we did in 2022. That's a 2-lane bridge, MTO 2-lane bridge. Sunridge, that's Resource Access Bridge up in Hannibal Inlet. That's Asphodel Norwood, east of Peterborough, that goes to their landfill site. Town of Espanola. The one I was talking about in Huntsville, that's the bridge that they ended up getting to go into those seasonal properties. And there's another one for, and you see on the top left-hand side is the outdoor heated pool, that lawn bowling building and the baseball diamonds are off of it. So just to really quickly summarize, there's the existing bridge. Like I said, we know now that it's constricting the flow, it's backing up water, it's hydraulically not very efficient, right? It's subject to issues when it comes to spring runoff. And it's closed or load posted. Next slide. So there's box culvert, people throw that around. Hey, I just put this box culvert in there, like I already gave you the example for Quinty. There's timing restrictions, there's permit restrictions, there's DFO approval, construction costs. You still got to do the removals because everything's got to come out of there, including the abutments, the cofferdam, dewatering, bedding and compaction, because the soil substrate underneath the channel, if it's mud, it's a big deal. If there's at least any granular material with it, it's a little bit, but very complex and expensive to install. Last slide. That's what we're talking about right there. Very simple. Right? We're talking about a bridge is good for 75 years. You'll probably be in your final term then, Jim.
I think he'll still be going.
I know I'll be the nursing home. Any questions?
Actually, no, very interesting. Thank you very much. I really appreciate your coming here and providing us with some really, looks like some incredibly interesting options. So,
And I don't want to take away anything from what any other competitor said. But we are the only ones that do the whole shebang from start to finish. And we understand the difficulties of the municipality. We understand your restrictions, your limitations, all of that stuff. You will find with us, like some of our competitors who weren't here, quite frankly, they will gladly talk to you as soon as you give them the PO. And they'll talk to you as much as you want up until the bridge is delivered or whatever the product is you're buying. And after that, sorry, can get back to you, or no response. We're in it for the long haul. That's why I like the venue for Good Roads, is because I know that you guys have other friggin' really complex, difficult issues that you're wrestling with. And it's not like somebody can show up with a suitcase full of bridges and say, hey, I'd like to talk to Don about bridges. Well, Don's busy working on something else, far more. Good Roads, and I encourage you to come see me, is a great venue because all that stuff's out of your head, right? You just want to talk to people, talk to vendors, network, whatever.
any questions? Well, seeing none, thank you again. We are going to go to lunch and then we're going to
Yeah,
do
yeah.
a tour. Okay, I'm just going to close off our council
Yeah.
meeting at this point. Could I have a mover and a seconder to adjourn today's meeting, please? Thank you, Deputy Mayor DeMarsh. Thank you, Councillor Valiquette. Be it resolved that council adjourn at what time, Karen? 11:29. All in favor? Thank you. Thank you. That was great.